Cotangent. Now, the difference between cotangent and tangent is the center and the asymptotes. Tangent is undefined at pi over 2 and negative pi over 2. But when we think about cotangent, let's look at our unit circle here. Cotangent is a little different than tangent. Not that different, but a little different. What's on the bottom of cotangent? It is sine. For tangent, cotangent, or cosine was on the bottom. But cotangent, sine is on the bottom. So, whenever sine equals 0, that's where cotangent is undefined. Where does sine equal 0? What angles?
0.
This point right here, at angle 0, we get 1 comma 0. And sine is 0. And then this one right here, at pi. At pi, we have negative 1, 0. And look at that y value. It is also 0. So guess where cotangent is undefined? 0 and pi. That's where your asymptotes are. So if you were to graph like a regular cotangent problem, a cotangent function, you would have an asymptote right here at 0 and pi. What's your center of that? Yep, pi over 2. And then we have our 2 satellite points. Oh, but this is kind of weird. What is pi over 4 of, or what is cotangent of pi over 4? So you get positive 1, right? So it'll be right here. And then what about 3 pi over 4? This is 3 pi over 4 right here. If I plug 3 pi over 4 in a tangent, that would, or cotangent, that would be, let's draw another unit circle. 3 pi over 4 would be right there. That's 3 pi over 4. If I divide x divided by y, what would you get? Now it's rad 2 over 2, rad 2 over 2. One of these are negative. What do I get if I divide those two together? I get negative 1. So look at that. Oh, wow. So what's different? What's the major difference between tangent and cotangent? It flipped. And so cotangent usually goes down. Now we can make it go up just if we just have to change the sign of the number multiplying to it. But this is cotangent usually. Tangent is a little different. Let me show you tangent really fast and then we'll graph this dude. Tangent has a center at 0. And its asymptotes are at pi over 2 and negative pi over 2. And tangent goes like this. It goes down, then up, the normal tangent. So you see how they're slightly different? They're slightly different, but they have the same kind of characteristics. The period for this is going to be affected by that guy. And so we're going to take pi and divide it by the number that's multiplying the x, which is pi over 2, which is the same as saying pi times the reciprocal of pi over 2, which would look like that. The pi's are going to cancel out. You get 1. My period is 2. So that's what I'm going to write down for my period. No phase shift. We don't go to the left or to the right. That's what this means. We don't go to the left or to the right. So that means we know what the center is. Before we find our center, let's find our first asymptote. Now, what is our first asymptote on this standard cotangent graph? Right here at 0. So the question is, at 0, no, not that. That's not my question. How do we make the inside of the cotangent, which is this, equal to 0? What does x have to be?
0.
That means at 0, we still have an asymptote. Okay? So at 0, we still have an asymptote. All right. What is the distance from this asymptote to the next asymptote, which is going to be way over there? What do we use to find that? Our period. And our period is, from here to here, is 2. Okay, so we got to break 2 up into 1, 2, 3, 4 spaces. Okay, so how do we do that? What is 2 divided by 4? No, just regular 2 divided by 4. 2 divided by 4 equals 1/2. So this would be 0, 1/2, and then 2 over 2, and then 3 over 2, and then 4 over 2. This simplifies to 2, and this one simplifies to 1. So our center is at 1. Now for our satellite points, you could just plug these in. But I know that usually we go up to +1 and then down to -1. But because there's the 1/2 out in front, we're going to go up only to 1/2 and down to 1/2. So your graph should look something like this. Now let's transfer that over to our graph. Now our graph over here counts by pi/6s, which doesn't help us right now. We need to be counting just by 1s. So I'm going to put a 3 right here because that's really close to pi, and I'm going to divide this up into 3 spaces. So I got 1 and 2. And then do the same thing with 6. So then we get 4 and 5. And now I have my x's on my scaled graph. So I have asymptotes at 0 and 2. Then after that I go 2 more spaces. That's going to be at 4. And then in 2 more spaces at 6. Now I just got to draw the rest of my cotangent graph. So I have a point in the center. I'm going to go to 1/2 there and to -1/2 right there, and I got my first curve. That's actually the same curve right there as the one on my cheat graph. All right, cool. Once you do that, you can do the rest of the stuff. The rest of the stuff is no problem. We go from -infinity to +infinity. For our range, our y-intercept doesn't exist because we have an asymptote on there. Our x-intercepts are at 1, 3, and 5. If I wanted to find all my x-intercepts, I would start at 1, and I would add 2n. N means however many times we have to add the 2. So like we can say n is 1. And so 1 plus 2 is 3. There you go. We can say n is 2. So 4 plus 1 is 5. There you go. And you can pick any number that you want, any integer you want to plug into n to find the other asymptotes. I'm sorry, to find the other x-intercepts. To find our asymptotes, we got 0, 2, 4, and 6. We take our first asymptote, which is 0, to define the rest of them. And then we add to that our period. You don't need to have the 0 there. I just do it for explanation purposes. So this defines all the asymptotes.